How does microgravity create flawless space-grown crystals? Imagine crystals growing in a place where gravity is almost zero. This environment is found on spacecraft like the International Space Station. It might sound simple, but it actually makes a big difference in how crystals form. When crystals grow on Earth, gravity causes tiny particles to settle and fluids to move around. These movements can make the crystals irregular and full of flaws. In space, microgravity stops these forces from disturbing the process. Without gravity pulling particles down or causing convection currents, crystals can grow slowly and evenly. This slow growth allows atoms to arrange themselves perfectly, creating larger and more pure crystals. Astronauts aboard the International Space Station perform experiments to grow these crystals. They use special tools like crystallization boxes and tiny tubes called capillary tubes. These tools help control temperature and chemical concentrations, which are very important for crystal growth. Because of microgravity, the crystals develop in a stable environment, forming what scientists call a depletion zone. This is a clear area around the crystal where the concentration of dissolved substances decreases steadily. This steady process helps produce crystals with a highly ordered structure, which is hard to get on Earth. Training astronauts for these experiments involves learning how to handle delicate materials in space. They must follow strict steps to set up the equipment correctly and keep everything stable during launch, orbit, and return. Astronauts also need to manage timing carefully, making sure the crystals grow for the right amount of time without disturbances. Their ability to troubleshoot and follow procedures precisely is key to the success of these experiments. The benefits of growing crystals in space are quite impressive. Pharmaceutical companies use space-grown crystals to better understand the structure of proteins. This knowledge helps develop new medicines that work more effectively and have fewer side effects. Because space-grown crystals are larger and more uniform, scientists can analyze them in more detail than crystals grown on Earth. This improved clarity can lead to new discoveries in medicine and materials science. In summary, microgravity creates perfect conditions for crystal growth by removing the forces that cause imperfections. This allows crystals to grow slowly and evenly, resulting in flawless structures. Astronauts play a vital role in conducting these experiments, applying their training to manage the unique challenges of space research. Their work helps scientists learn more about materials and medicine, making space-based crystal growth a powerful tool for scientific progress.